This conference will now be recorded.
All right, everybody. Welcome to session number 2 of our Satellite Book Club. This is a new form for reaching out to the field offices and our meteorologists that are interested in some of the differing satellite capabilities out there to help you accomplish your mission. Today we'll be talking about fire. We hope to bring in science officers, forecasters, and satellite liaisons in the subsequent weeks. And we would encourage you, if you have a novel use of satellite data in your office, whether it's RGBs or scatterometer winds, whatever it might be, feel free to reach out to our team here, David Blutis and Lee Byerly, who have done a great job helping to organize this. They are also available to help you with anything related to data access and AWIPS configurations for satellite data in particular. I'd also like to thank Brian Mata from the Forecast Decision Training Division and our colleagues in the JPSS and GOES-R program who have been instrumental to helping us with this and bringing new satellite data to the field. So just a few things before we get started with today's presentation. This session is being recorded, and this will be generally short. There'll be about a 15-minute presentation, and then there'll be a little time for Q&A. So feel free to ask your question in the chat room if you want to jot it down. Otherwise, save it for the end, and you can unmute and ask your question then. There'll be a feedback survey if there's ways that we can make this more applicable to you. And if you have any needs, particularly for the SUs in the audience, if you need help creating training materials for satellite data, there's a great training team that we have. Jorel is part of that team, and he'll talk a little bit about training. So never feel like you're alone in that respect. We all realize you're busy, different things, and for your local CWA, the training team for the Weather Service can certainly help with that. So without further ado, I'd like to bring in Jorel Torres, who's a JPSS satellite liaison at CIRA in Fort Collins, Colorado. If you're unfamiliar with, the liaisons are positioned by the satellite programs to facilitate interactions between Weather Service forecasters and researchers. And so he's producing the satellite training in the JPSS training modules. If you might have taken the SAT-FC J, many of our science officers took that, and he's also been hosting satellite teletraining before, and he's going to be talking to us about the VIIRS Fire RGB imagery. So this is going to be a great presentation. Thank you, Jorel, for being with us, and go ahead.
All right, thank you, Jordan. I'd also, before I start, I would like to also thank Dr. Curtis Seaman as well, who's my co-author. He is the product developer of these RGBs, and also he provided some of the non-AWIPS imagery that I will highlight today. And then I would also like to thank Carl Dierking from GINA and also Mike Lawson, a forecaster from WFO Anchorage, who provided me some of the Alaskan AWIPS RGB imagery to highlight today as well. So let's get right into it. Let's see here. So main point here is which VIIRS RGBs are we talking about? We're specifically talking about the VIIRS fire temperature RGB that you see there on the top right, where you see an animation of the Swan Lake fire, which was being observed just south of Anchorage during the summer of last year. We're also talking about the VIIRS Dayland Cloud Fire RGB as well, which is observing another fire over Alaska. Now, these RGBs are currently available in AWIPS for Alaska NWS users for fire monitoring. These RGBs are derived from the Visible Infrared Imaging Radiometer Suite, or VIIRS instruments, on board SMPP and NOAA 20, where these RGBs provide a high spatial resolution of 375 meters and 750 meters. They also provide a higher temporal resolution near the poles compared to the mid-latitudes. So essentially more frequent overpasses over the poles. And the data that goes into AWIPS for these RGBs are acquired from the LDM via the GINA direct broadcast antenna, where the data latency is approximately 30 minutes. Now, these VIIRS RGBs, well, let me take a step back. If you're very familiar with satellite fire monitoring, these VIIRS RGBs may appear similar to what you would or what you may have seen from the GOES 16, GOES 17 RGB versions. That is the GOES fire temperature RGB and the GOES dayland cloud fire RGB. Now, this particular seminar will highlight, I'll speak about the VIIRS RGB applications, how these VIIRS RGBs are compared to the GOES versions, along with highlighting the current satellite training, where users can become more familiar with the RGB applications and limitations. And then additionally, I will highlight that these VIIRS RGBs are available for Alaska users. However, currently they're not available for CONUS forecasters. And I know we've had some initial discussions and initial progress with TowerS and others to try to get these RGBs into CONUS forecasters' hands. Now, the next two slides, I will speak about a little bit more in depth on these RGBs and the imagery interpretation as well. So the first one here is the VIIRS fire temperature RGB. And then the bottom of the slide highlights a table that depicts the RGB recipe or the RGB makeup of this RGB. Now, with the VIIRS fire temperature RGB, it can be utilized to assist users in fire location, fire detection, but then also in a qualitative manner infer the fire intensity, with a particular color scheme with the pixels. So red pixel, it will go from red to orange to yellow to white when you're observing the fires. Red pixels indicate cooler fires. As the fire gets more and more intense, the red pixels change to go from red to orange, orange to yellow, yellow to white. Yellow and white pixels indicate the most intense fires, in which then if the fire is so intense that it exceeds its saturation temperature, you'll get a saturation and or fold over effect, where the color will change to a bluish green color, which you actually see here in the Zitsiana fire example here in the northern periphery of the fire. And you can also infer that the northern periphery of this fire is the most intense portion of the fire at this particular timestamp. Now, in addition to the fire characteristics, there's also some microphysical characteristics as well that can be observed in the scene, where liquid water clouds are depicted in blue, and then also the higher ice clouds are depicted in the dark green colors, denoted by my cursor. In addition to the VIIRS fire temperature RGB, we also have what we call the VIIRS dayland cloud fire RGB, and hence within the name, this particular RGB can only be utilized during the daytime. Now, with this RGB, a little bit different from the fire temperature RGB. Well, first of all, of course, you can observe the fire location, fire detection. However, with this RGB, it incorporates the vegetation channel within the RGB spectra, in which this RGB is very sensitive to vegetation health, where you can observe, say, burn scars for hydrological applications. But then in this RGB, it's also sensitive to fire smoke, which you can see here from the Swan Lake fire, where you see this bluish gray colors, diffuse signature just southeast of the fire there. Now, within the particular imagery here, what you have is the green pixels indicate healthy vegetation, or different shades of green indicate healthy vegetation. The brown colors indicate bare ground or old burn scars and or urban areas. You have the predominant cyan colors, which can be depicted as either snow and or cloud cover as well. I think that's it for the most part there. Now, here's a slide here that's highlighting pretty much a nice little comparison between both RGBs and how one can complement another. In this case, observing the North River fire in Alaska. So you have the VIIRS fire temperature RGB on your left, VIIRS dayland cloud fire on your right, where you're observing this fire here. And with the fire temperature RGB, you can see just the rapid changes in fire intensity, as you see some yellow pixels and potentially some white pixels, and also it looks like some brief saturation occurring on the southern periphery and also the eastern portions of the fire as well. So you see those rapid changes in fire intensity as you have incoming convection from the east, where you can see and observe the liquid water clouds in blue, and then also your ice clouds in dark green. Now, with this fire temperature RGB, it is insensitive to smoke, so you can't really see where the smoke is in this case. Also note with the VIIRS fire temperature RGB, it can also, in the aspect of observing the fire, you can observe it during the nighttime as well. Now, conversely, with the day land cloud fire RGB, it can only be used in the daytime. It is very sensitive to smoke, which you can see the fire smoke plume here that is emanating from the fire to the southwest there in the blue grayish tint. And then also it's sensitive to the vegetation health as well, as you can see the relatively newish burn scars within the within the fire perimeter there, as you have incoming convection from the east depicted in the cyan there. Now, I highlighted to you some of the Alaska VIIRS fire RGB examples. Now, the question becomes, how do the VIIRS fire RGBs appear over CONUS? So the following slides will highlight some non-ellipse imagery of some select fire cases, and these images are courtesy of Curtis Seaman at CIRA. Here's an example of the campfire. I assume a lot of folks on this call are quite familiar with this fire that happened back in 2018, and this is just a timestamp at 2036 Z on 8 November 2018, where you have this RGB at 375 meter resolution, spatial resolution, where you can see the aerial extent of this fire. And as I mentioned, with this RGB, it's very sensitive to smoke, where you can see the smoke plume that has advected towards the west, implying strong easterly surface winds, and you can see a very in-depth smoke plume, a very thick smoke plume there along the coastline and also offshore. Now, in addition to this, you can, with the high spatial resolution, you can also see smaller fires, which you can see a small fire hotspot just east of the Bay Area, denoted by my cursor there. And then here's the subsequent VIIRS fire temperature RGB at the same time at 750 meter resolution, where you see the fire intensity, the differences in fire intensity here, and the very intense fires in the yellow and white pixels in the western portion and also in the southern portions of the campfire there. Here's an additional example over to CONUS as well. This one's just comparing the VIIRS true color, and I'll toggle back and forth here with the VIIRS fire temp RGB here, where both of the products are at 750 meter resolution. With the standard VIIRS true color, it may be a little bit more challenging to see where like the fire perimeter is or where the fires are located. Sure, in the true color, you can see where the smoke plumes are at, or if you're very familiar with looking at satellite imagery. So like, for example, in the VIIRS true color here, I see a little smoke plume here by the Colorado-Kansas border in southeastern portion of Colorado. I also see a smoke plume over here in western New Mexico. Those are two that stand out. And then there's also this other plume here, which I'm not for sure where that's coming from, just based on looking at the VIIRS true color. However, when I toggle back and forth with the VIIRS fire temp, your fires stand out pretty significantly here, where those fires can correspond with the smoke plumes, such as the one in southeastern Colorado here, the one in western New Mexico, and then looks like there's some other fires throughout southern and southeastern Colorado and also in Oklahoma. But what's interesting with this particular case, as you look at the date of 17 April 2018, there was actually a strong low pressure system that came through the area and produced very strong southwesterly surface flow, and it lofted a lot of dust and sand from the Great American Sand Dunes in south central Colorado, advecting all of that dust towards the eastern plains and also the Front Range as well. I believe there was a lot of visibility reductions along or in Denver and also at the DIA or the Denver International Airport. Now I'll transition here to the differences between the VIIRS and also the GOES RGB and the different versions of the VIIRS and the GOES here, where you see the particular Starbuck fire here along the Kansas-Oklahoma border, where the VIIRS version, the VIIRS RGB here, you can see that it provides that high spatial resolution, more fine details of the fire perimeter, and also see where the most intense parts are, especially in the northeastern portion of that fire. And but with the GOES version, it's a little bit more pixelated because it's at 2 kilometer resolution, and it appears it doesn't capture the intense portions there in the northeastern portion of that fire as well. However, you have to remember with GOES provides that higher temporal refresh rate, and the VIIRS doesn't offer that. It has a coarser temporal resolution of twice a day per polaroid satellite. So just remember how how the VIIRS and also the GOES RGBs can complement one another. And then here's a comparison of the Dayland Cloud Fire RGB as well. In this case, of a different fire over there by the Georgia-Florida border of the West Mims fire, where you can see the relatively new burn scar of the fire with the ABI, although it is pixelated a little bit compared to the VIIRS, where the VIIRS provides more detail and also observes some smaller fires that are still active within the fire there. So just note that. And then also provides a little bit more detail of the clouds as well, and also some of the cloud shadows that you see there. And just note that with the burn scar aspect with the RGB, you can employ this for hydrological applications and flash flooding applications as well. And one additional question that is out there as well is there, so you have these VIIRS RGBs, is there any satellite training available for users to refer to? And the answer is yes. I have worked with Curtis Seaman as well, along with Gina and a few other folks in developing these satellite training reference materials. If you're not familiar with the satellite training lingo, these are quick guides, which are 1 to 2 page reference documents that highlight the VIIRS fire temperature and the VIIRS Dayland Cloud Fire RGBs. These 1 to 2 page reference documents highlight to users what is this RGB, why is this RGB important, what is the RGB recipe, what are the product applications, limitations, and also additional case examples, and how do you interpret the RGB imagery as well. Now there are corresponding links here at the bottom. If you're a NOAA user or if you're a non-NOAA user, you can go and click and you can find these quick guides for your use. Additionally, we have what we call quick briefs as well, which are essentially product application videos that go a little bit more in depth to the product applications and limitations as well. And you can go to these subsequent links to check out those videos. But with that, here's my summary slide and future outlook as I come to a close. So essentially, you have these VIIRS Fire RGBs that are currently available in AWIPS for Alaska NWS users. And this seminar just provided an initial insight for users that are not familiar with these RGBs of what these RGBs are and how they can be employed in operations. And the initial plan is just to continue working with TowerS and others to get these VIIRS Fire RGBs and AWIPS for CONUS, since they're not available for CONUS forecasters just yet. And but once these RGBs are available for CONUS forecasters and in their AWIPS systems, more training opportunities can be explored, where I can develop more training modules, reference materials, teletraining opportunities, focusing on these CONUS examples. And of course, all the training focuses on how the user can employ these RGBs in operations and for IDSS purposes. But with that, I thank you for your time. And if you have any questions, don't be hesitant to email me or ask away. But once again, thank you for your time and inviting me to the seminar.
Thanks, Jorel, for that great presentation. At this time, we'll open up to questions here. Feel free to unmute your device if you'd like to ask a question, or as we mentioned in the beginning, if you'd like to also type a question in the chat room, you could do that as well, and we will field those then. So does anyone have any questions for Jorel?
Hey, Jorel, this is Mike Lawson. Got a question. Do you know, are these VIIRS products at all? Of course we utilize them here in the office, but is there any examples of them being utilized by the fire community, whether that be like AICC Met up here or a GAC Met in the lower 48? Because it looks like the resolution is incredible, and they've got capabilities to detect even the smallest fires and hotspots. I feel like it's a user group that could really benefit for fighting these things on the front lines.
Um, I apologize. You're breaking out on my end. Could by chance we have that question typed in the chat box by chance, or in another method? Because for some reason my end here, the question was breaking up.
Yeah, Jorel, this is Jordan. Can you
Yeah,
hear
did you
me?
hear me? Yeah, you're breaking up a little bit, so I wasn't for sure what the question was. But oh, I do see the chat box here on the GoToMeeting here. So I'll try to address it that way if that works. Let's see here. Why aren't the polar orbiting routinely in AWIPS for CONUS use? That's a pretty complex question. Essentially, to my knowledge, and I know other folks can chime in as well, but I know one of the issues is bandwidth issues. There's only so many products that you can provide over the SBN for users. And I know we have a lot of GOES satellite imagery that goes into AWIPS, but then you also have to think about all the non-satellite data sets that are going into AWIPS as well, such as the model data, radar data, etc. And I know we've been, I know that TowerS has been working on trying to get more polar orbiters data sets into AWIPS as well. So I hope I answered that question for you.
So, hey, Jorel, this is Schoberg. One of the things you might mention or could be mentioned is, whatever is needed, National Weather Service can request that. And so to get new things on to the baseline AWIPS, we can go through that process. But we're more interested in getting it out to people as soon as possible, having them look at it, evaluate it, provide feedback, and then we can do a lot of things. We've done it in Alaska, we've done it in other places to kind of get the products available while we're looking at formalizing it through AWIPS, through the AWIPS baseline. So did you catch all that?
Jorel, are you there?
I'm here. Sorry, the audio has been kind of out on me on this side.
I think Bill was just reaffirming the JPSS program support. I think you can see in the chat window there Mike Lawson's question. Jorel, are you there? You with us?
I'm still here on this side, Jordan, but you guys are breaking up on my end.
Okay.
I apologize for the inconvenience there.
We can hear you fine if you want to answer the questions.
Okay, could you, as I mentioned before, could you type it into the chat box or into the Google interface? Either way, just because I'm not hearing what the questions are. Let's see here. Okay, so I just received your inquiry there, Jordan. So it says, are these products being used at all outside of the NWS community? Let's see, the AICC or the GACC METs. Let's see here. Fires ramp up this season. I'm actually not for sure about the AICC or if the GACC are utilizing the imagery at the moment. I could probably ask Curtis when I get done with this seminar to see if he knows, or I can also inquire from Carl Dierking to see if there are any other non-NWS or people outside the NWS community that are utilizing that imagery.
This is Curtis Seaman. Can you hear me?
Yep, we
Yes,
got
Curtis, go ahead.
So the Alaska Fire Service is using these RGBs in their operations. We are trying to figure out the best way to get these products out to similar users in CONUS. But as far as I know, they're not being used yet. But that is our goal, to get them out into the field to both National Weather Service and non-National Weather Service users.
This is Bill Schoberg, and the other thing is these products have been discussed at our Fire and Smoke Initiative telecons, and I know that the U.S. Fire Service has been looking at them. We can see if they have been able to apply it at a particular location or fire and get some feedback from them.
Okay, thanks everybody. Due to the technical issues, we'll have to cut the Q&A a little short here. I want to thank Jorel for volunteering to present today. And his email address is up there on the screen, or if you use Twitter, feel free to reach out to Jorel. I know he enjoys interacting with the field and bringing this data out to you. Hope everybody continues to stay well during this challenging time. I appreciate you taking the time to join us today. Next week, May 28th, 2 p.m., we got Dr. Chad Gravel, Techniques Development Meteorologist in Southern Region. You might know him from the OPG. He did a great job running a lot of activities there previously. He's got an interesting presentation next week on the importance of quality observation data for real-time gridded analyses. So I look forward to his perspective and hope you'll be back to join us. There'll be more on this session. It was recorded from the Tower S team if your colleagues missed it. The recorded version, I believe, will be posted by tomorrow. And with that, I will wish everybody a restful Memorial Day weekend. Take care and thanks for joining us.